Hello and welcome to this solution video. I hope you're doing well. If you like this effort of mine to solve this paper, then like this video, share with your friends and subscribe to Math United. Let's start with question number 1. When the polynomial ax cube plus 4x squared minus 7x is divided by this binomial, the remainder is 33. Find the value of constant a. So the easiest one, we can use remainder theorem in this or factor theorem. So since they're saying the remainder is 33, we'll call it remainder theorem. They have not any difference here. So remainder theorem. So what do we do in remainder theorem? If x plus 2 is equal to 0 or x is equal to minus 2, remainder theorem says that this minus 2, if substituted here, in this it will give us the remainder. So x equal to minus 2, if substituted here in this polynomial, let's say polynomial with minus 2 as the substitution. So I will substitute x, every x with minus 2. Done. Okay, so now I will, this has to be equal to 33. I will open up everything now. So minus 2 cube will be minus 8. This will be positive 4 times 4, 16. Then plus 14 minus 5 equal to 33. Let's simplify this. It will be 8a minus 8 plus 16, and then 14 minus 5 is 9, goes there. So 8a is equal to 24. A is equal to 24 divided by 8, which is 3. And that's what they say, find the value of constant a, which is 3. Okay, question number 2. Solve the equation secant theta cos theta minus 60 degrees equal to 4 between minus 180 and 180 degrees, and theta is not equal to both of them. All right, so let me write this. Since this is secant theta, this is cos, so let me convert this secant theta into cos. 1 over cos theta, that's what secant theta is, and then cos theta minus 60 equal to 4. Okay, and I have to solve this one. Basically I have to find theta. Let's open this with identity cos a minus b. What is the identity? It says cos a cos b plus sin a sin b. Okay, that's what I will substitute here and multiply with 1, which is the numerator of this. So it will become what? Cos a cos b plus sin a sin b. So a is theta and b is 60 degrees divided by cos equal to 4. So let's separate them. Cos theta cos 60 divided by cos theta, so that this cos theta cancels, and this plus sin theta sin 60 divided by cos equal to 4. So since it is cancelled, cos theta is the only, or cos 60 is the only one left, which is half. The value of cos 60 is half, plus sin theta over cos theta becomes tan theta, and multiplied by cos sin 60 is square root 3 over 2. And this is not angle, okay? The theta is the angle with tan, or let me undo this and write square root 3 over 2 first, so that it does not confuse with angle. That happens many a times. That looks better. Now both of them have same denominator as square root 2, so we can write it like this. Equal to 4. Okay, this 2 will go and multiply with 4 cross multiplication, so 1 plus square root 3 tan theta equal to 8. And now I have to isolate theta, so this 1 will go here, so square root 3 tan theta equal to 8 minus 1, which is 7. So let me complete it here. Tan theta will be 7 over square root 3. Yeah, 7 over this is square root 3 cross multiplied. So theta will be positive inverse of 7 over square root 3. Why did I say positive? Because they said between minus 180 degrees and 180 degrees. And where is tan theta? Positive. Tan theta is positive in first quadrant as well as the third quadrant, right? But since they're saying minus 180, this is not third quadrant for us anymore. So minus 180 from this will be here. So this becomes the quadrant between minus 180 and minus 90. Okay, 270 degrees same as minus 90 degrees. So this answer first. Let's say what is this answer first. We need to find what is tan inverse 7 square root 3 to get this acute angle and this acute angle. Obviously both of them are same. Let me use my calculator for this. By the time I'm doing this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting is 76.1. So these two acute angles are 76.1 degrees. So it means that first answer from minus 180 till positive, this is also positive 180, okay, in this direction also is this. So first angle I will say will be this one, 76.1. This is the first answer itself. Now second will be in this direction because it is from minus 180. This will be the second answer, this angle, which is 76.1 degrees more than minus 180. So it will be minus 180 degrees plus 76.1 degrees. So it will be minus 103.9 degrees. That's the solution, two solutions of this particular equation. Question number 3. The diagram shows the curve y equal to 6 to the power minus half x. 6e to the power rather. Okay, the points on the curve x coordinates are 0 and 2. These are 2, A and B. The shaded region is enclosed by this line, and the curve, okay, through a parallel line to the x-axis and y-axis. Okay, find the exact gradient of the curve at B, this. So let's go backwards. To find the gradient of curve at B, we should know the x coordinate first. We know it, 2. So basically at x equal to 2, that's what they're saying. Second thing, we should know the differentiation, derivative of the function, which is dy over dx. So that's what we will do, right? So we will find dy over dx, and then because we know x equal to 2, we'll just substitute it. So whenever a multiple constant is multiplying with a variable part, it leaves as it is, means 6 will remain 6, we will not even touch it. Now we'll focus on the exponential part, which is we copy this whatever it is and then differentiate what was the exponent. So differentiation of minus half x will be minus half. So now we can cancel this and this, so it becomes 3 minus, because of this minus it will become whole thing will become minus 3 e to the power minus half x. This is the differentiation, and now we want to find the gradient at B. So at B, dy over dx is equal to minus 3 e to the power minus half, and we will write x equal to 2 in place of x. So 2 and 2 cancel out. So it becomes minus 3 e to the power minus 1, and exact, they want exact. So to make it positive, we will just reciprocate e only. Minus 3 remains on top. E will become positive when it becomes a denominator. That's it. Find the exact area of the shaded region. That is the B part. So my plan for this area will be that I'll find the area under this curve first. This one, this yellow colored. Alright. Then I will subtract that area I get from the rectangle. So area of this B part, okay, shaded part will be the area of the rectangle I see minus area under the curve. So after the rectangle, if we remove this yellow part, we'll be left with this yellow shaded part, white shaded part, and this will be our answer. Okay, so area of the rectangle first. We know this is the width and this is the length. We know the width, we don't know the length. This basically the y coordinate of A. What is the y coordinate of A when x is 0? That's my first thing first, so I will do it here. When x is equal to 0, y is what? I will just substitute 0 here. 6 e to the power minus half times 0. Okay, what is minus half times 0? 0. E to the power 0, 1. So y is equal to 6. That is the y coordinate here. So the coordinate here is 0, 6, and I will use that one here. So this height is 6, this length is 2, so the area of rectangle becomes 6 times 2, which is 12, but I'll do it later, minus now area under curve. For area under curve, we will just integrate our equation of the graph, which was from 0 to 2, and 6 e to the power minus half was it. And we'll just integrate this. So 6 again is multiplying, we'll keep it out. E to the power minus half x, again in integration also, if it is a linear exponent, we just copy it again. But in this case we divide, not in differentiation we multiplied, right? By minus half we multiplied here. Here we'll divide by minus half. So minus 1 over 2. I'm not writing 1 over 2 here because the denominator of denominator is numerator. And that's it. And from 0 to 2. And we'll just evaluate this. Let me do it here. So minus 1 and 2 times 6 will be 12. So minus 12, let's keep it outside. E to the power minus half times 2 minus e to the power minus half times 0, and I'm ignoring c because c will be with both and c minus c is 0, so I'm ignoring it. Usually people ignore it, I'm doing it. So 2 and 2 cancel here. So minus 12 e to the power minus 1 minus e to the power 0. Yeah, minus half times 0 will be 0. What will that be? Minus 12, 1 over e minus e to the power 0 is 1. And exact area again they're saying. So we will do what? This is where we were continuing. So this minus 12 rather. Minus 12, 1 over e minus 1. Yeah. So let me, because they say exact, so I'll open, because this is 12 and this is also 12, so I'll take 12 common. Then we have 1 here. This minus minus becomes plus and 12 is already out, so we'll be left with, and no sign change, 1 over e minus 1 because this positive does not change anything inside, it will remain this. 1 and minus 1 cancel. Answer is 12 times 1 over e, which is 12 over e. This is the exact area of the shaded part given in the graph, this one. All right, let's go to question number 4. Sketch on the same diagram the graphs of y equal to absolute 3 minus x and y equal to 9 minus 2x. So sketch, since it's a sketch, so we just need approximate graph. First I will just draw the graph of 3 minus x, right? So 3 is the y-intercept and minus x, its gradient is minus 1. So 3 is positive 3. So let me say 1, 2, I need, in the second one I need 9. So I need a smaller one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 and 1, 2, 3. I needed 3 for this one. Okay. So minus x is that it is going down. Okay. So the gradient will be 1 when 3 and 3. These two are the 2 points through which the graph is passing. So let me draw a line which is passing through 3 and 3. This is the graph of 3 minus x. But because of absolute, this absolute sign, this negative part must go. This negative part will be reflected because in absolute there is no negative. So it will become positive, and which will be like this. It will become a V-shaped graph whose x-intercept is 3, y-intercept is also 3. All right, done. This absolute part done. Second one, 9 minus 2x. 9 is the y-intercept, which is here, and minus 2 will be the gradient. Again, it is going down, but keep in mind that the gradient is minus 2. So minus 2 will have 4.5 on the x-axis, then only it will be 4.5 of run and minus 9 of rise, which is down 9. So 1, 2, 3, 4 and 4.5. This is 5. Okay. So 4.5 here it will pass through. Okay. So I'll just draw a line which passes through 9 and this point. So okay. Now it is passing through 9 as well as 4.5. So this is the sketch, and we should write as much as possible. So this is x-axis, this is y-axis. 9 we have written, this we have written. We can put arrows here. This is 3, this is 0, and we have shown every part of it. This is the graph. Now solve the inequality this. Okay, so we can see that there is only one answer here. So what would that answer be? To find this point of intersection, we will equate the changed sign of it. Why? Because it is intersecting at the reflected. This part was reflected, right? Because it is crossing there at reflected, so we'll change the sign of 3 minus x. So it will be minus 3 minus x, and because we are signing point of intersection, not the inequality, so 9 minus 2x. I'm writing equal sign here to equate them. So it will become 3 plus x, no, minus 3 plus x equal to 9 minus 2x. So let me bring it here. So 2x plus x is equal to 9 plus 3. So 3x, and exactly it is coming out to be 12 divided by 3, 4, as it looks like. Makes sense, right? It's just above this. That means this is 4. And but this is solve the inequality. This is not, this is the point of intersection we have found. So I will just say that when is this graph, this absolute graph, above the other graph which is here. Otherwise in the whole part only this graph is above. So this graph is above after x is equal to 4 in this area. So the solution of this will be x is greater than 4, not equal to, because there is no equal sign here. That's the solution. Question O. We have C also. Use logarithms to solve the inequality 2 to the power. Let me do it here. 2 to the power 3x minus 10 less than 500. Okay, so let's give natural log to the both sides. So when this exponent becomes the coefficient in natural logs also, so 3x minus 10 is the coefficient now, and we are just left with natural log of 2 less than natural log of 500. So let's evaluate this and this and correct to 3 significant figures. So that's what we'll do. First, what is natural log of 500? 6.21. 46. Let me write more digits. Last step I will change it. So natural log of 2. 0.6931. 0.6931 3x minus 10. This is what we have to solve now. So we'll multiply this with 3. 2.07944. 2.07944x minus, it will be 6.931 less than 6.2146. Okay, let's bring this minus 6.931 to the other side. 2.07944x is less than 6.2146 plus 6.931, and let me direct it right. X is less than 6.2146 plus 6.931 divided by cross multiplication 2.07944. Let's see what it gives me. By the time I do this, I would request you to like this video if I like my work, subscribe to Math United, share this video with your friends. Only 8% of my subscribers are my viewers. 92% don't subscribe. So please subscribe to motivate me to make many more videos like this in future too. So what I'm getting is 6.3214. So I can write 6.32. So C part is done. What about D part? List the integers that satisfy both of the inequalities. This. Okay, so let's draw a number line. Both the inequalities they're saying. So the solution of the first one was x is greater than 4. Yes, x is greater than 4. And second one is this, and is it exactly same? They're asking 3x minus 10 less than 500. Yes. So the first one was, the solution of this one was x is greater than 4. So 1, 2, 3, 4. Okay, and the solution of this one is 6.32. So 5, 6, and 6.32 will be somewhere here. It is less than that. Yeah, less than 6.32. So they're saying list the integers that satisfy both of them. What are the integers in both of them? So 4 is not part of it. So 6. So 5. 5 is the one, and 6 is also the one. So because it is not equal to 4, so 4 will not be included. Only 5 and 6 are in both of them. Can you see this and this? What are the two integers which are here? 5 and 6. So we'll say 5 and 6. These are the two integers which satisfy both the inequalities. Question number 5, A part. Find the quotient of this divided by 2x plus 1 and show the remainder is 6. Okay, we could have used remainder theorem, but since we want quotient as well, so we'll use long division method. 2x plus 1 divides 6x cube minus 5x square minus 24x minus 4. So 2x and 6x cube, I need 3x square to multiply with 2x to get 6x cube. So 3x square multiplied by 1 will give me positive 3x square, and they will change their sign because we are subtracting them. This cancels. Minus 8x square minus 24x minus 4. Now 2x to be converted to minus 8x square, so we need minus 4x. And 1 times minus 4x will be minus 4x. Change their signs to subtract. Cancels, and this becomes minus 20x minus 4. 2x and minus 20x, we need minus 10. So minus 20x, and minus 10 times 1 is minus 10. Okay. So it becomes positive, and they cancel out, become positive, right? So we'll be left with 6. 10 minus 4, 6. And they said, show that the remainder is 6. So quotient is found. This one, and remainder is 6. Done. Hence, find this definite integral, giving your answer in the form of this and b. Okay. So this is this exactly same. Yes, exactly same numerator and exactly same divisor. So we can straight away write this as integration from 2 to 7, and quotient is 3x square. 3x square minus 4x minus 10 dx. This is complete, and then we have positive 6. So plus 6 still divides 2x plus 1 dx from 2 to 7. Okay, so the integration of this algebraic part is easy. We can do it here. So it will be 3, the exponent goes up by 1, so 3x cube over 3 minus 4, exponent goes up 2, and the same we divide here, minus 10x plus c 2 to 7. Then we have plus 6 is a constant, so we can keep it out. 1 over 2x plus 1. It is a linear reciprocal function, so we can straight away write the natural log of 2x plus 1. Right? Whenever we have 1 over a linear, we do this and divide by the differentiation of whatever is the denominator, which was 2x plus 1 in this case. So the differentiation is 2 of 2x plus 1. The differentiation of 1 will be 0, so just 2. Okay, and plus, let's say d from 2 to 7, and let's substitute the value 7 and 2 now. So I'll substitute here. 3 and 3 cancel. So 7 cube, which is 343. This also cancels. Minus 2 times 7 square, which is 49. Minus 10 times 7. This time let me keep c, and I will subtract when I substitute 2 from here. So 2 cube, which is 8, minus 2 square, 2 square, which is again 8. Yeah, 2 square is 4, 4 times 2 is 8. 10 times 2, 20, and plus c. Plus 6 times natural log of 2 times 7 is 14 plus 1, 15. And 2 is not part of it, so I should not write it. 15 should be this, and divide by 2. 2 is not inside natural log, it is outside. Minus natural log of 2 substituted here. 2 times 2 is 4 plus 1, 5 over 2 plus, okay, d and minus d I can cancel it. Plus d and minus d, they cancel out. We should not actually, most of the people don't write it, but it's a habit. 343 minus 198, yes, minus 70. This C will cancel with this C, so no need. 8 minus 8 cancel, so minus and minus 20 becomes plus 20, plus 6 times, I can take 2 also outside, both of them have 2, so it will not cancel, confuse, so we'll be left with 15 divided by 5, because they are subtracting. This content will be divided by this one, and done. This cancels. So they want what format? A plus natural log of B. So 70 and 98, oh, let me do it. 363 minus 168. 363 minus 168. 195. Plus 3 natural log of 3, and they don't want anything in front of natural log. That means this 3 will also become the exponent. So 195 plus natural log of 3 cubed. Final answer will be 195 plus natural log of 27. Moving on, question number 6. The diagram shows the curve with parametric equations, this and this, x and y, given separately in terms of t. However, the curve crosses y-axis, so this is x and this is y. There is no t here. Okay, at the point B, okay, the gradient of the curve is 12 here. The gradient of this one, which is dy over dx, is 12 at B. Okay, find the exact gradient of curve at A. So we have to find what is the gradient when x is 0. Let's start with dy over dt. Because for dy over dx, we need dy over dt first. So dy over dt, there are two parts, variable parts, which are multiplying. So we will use product rule. I will use 40 as 40, but I will differentiate natural log t, plus then I will differentiate 40 and I'll leave natural log t as it is. So what is the differentiation of ln t? It is 1 over t. So 4t times 1 over t, and t can cancel here. Plus differentiation of 40 is 4 ln t. So both of them has 4, so I can write 4. 1 plus ln t will be dy over dt. Okay. Now I need dx over dt. So I'll differentiate this one. 3 is a multiple constant, so leave it 3. I'll just differentiate this one, which is 1 over 2t minus 3, further multiplied by differentiation of the content of natural log, which is 2. Because differentiation of 3 will be 0, differentiation of 2t will be just 2, which is positive 6 over 2t minus 3. So dy over dx by chain rule will be dy over dt multiplied by dt over dx. So dy over dt is 4, 1 plus natural log of t divided by this, because multiplying by the reciprocal is dividing. So 6 will be here, and 2t minus 3 can be written up, denominator of denominator. That's how I divided it. Okay, reciprocal of 6 over 2t is 2t minus 3 over 6. That's what I've done. I can cancel this also. Okay, that's dy over dx. Now we have to find the exact gradient at the curve at A, and at A we know that x is equal to 0. This is equal to 0. So let's say what is t in that case, because we need t. The answer is, the differentiation is in terms of t. So 0 is equal to 3 natural log 2t minus 3. So if I, okay, first I need to take this 3 and make it an exponent. So 0 equal to natural log of 2t minus 3 cube. And now to remove this natural log, it will become e to the power 0 equal to 2t minus 3 cube. And e to the power 0 is 1. Let's cube root both sides to get rid of 3 also instead. So cube root of 1 is 1. 2t minus 3. 2t equal to 4. So t comes out to be 2. Does it make sense? Okay. We can't see t, so let's see. The t is equal to 2. So now we can say that at a dy over dx when t is equal to 2 is 2 1 plus natural log of 2. 2 times 2 is 4. 4 minus 3 is 1 over 3. So finally it comes out to 2 over 3, 1 plus natural log of 2. That's it. This is the gradient in exact form. Okay. So this 12 was not used. Let's see if it is used in B part. So that the value of parameter t at B satisfies the equation. Okay, at B. So obviously they're asking because they have given 12. So should I do it here? No. Let me do it properly downwards. Okay, so what is dy over dx? This was the one. 2 over 3, 1 plus natural log. Let me keep it visible. So 2, let me change it. Yeah, 2, 1 plus natural log of t, 2t minus 3 over 3 is equal to 12. That's what they gave us, right? The dy or dx at B. At B. And they are saying they're isolating the t, which is this one, because natural log t is on the other side. So I need to focus on isolating this one. So first I can cross multiply. This 3 will multiply with 12 and 2 will divide. So this is what I'm going to do now. 1 plus natural log of t, 2t minus 3 is equal to 12 times 3 divided by 2, 6. Okay. So 2t minus 3 is not closed here. It is closed here. All right. So 1 plus ln t will be taken this way. So it will become what? 2t minus 3 equal to 18 over 1 plus ln t. Yeah. Now I'll take this 3 to the other side. So it will become what? 2t equal to 18 over 1 plus natural log t plus 3. And now this 2, I'll divide all of them by 2 so that this 2 is taken care of. So 2 and 2 cancel here, this 2 cancel here, which gives us 9, and this 2 does not cancel, and this is exactly what we are getting here now. T is equal to 9 over 1 plus ln t plus 3 over 2. This is what they were asking us to show. Done. Use an iterative formula based on the equation in B. Okay, this one. 9 over 1 plus ln t. Okay. Giving your answer. Correct to 3 significant figures. Answer should be 3 significant figures. Okay. Use initial value of 5. Give result of 5 significant figures. Alright. So, let's do it. First, let me write what was it equal to. T equal to 9 over natural log 1 plus natural log. Yeah. 1 plus natural log of t plus 3 over 2 as far as I remember. Okay. Now we have to start with t1 equal to 5. That's what they're saying. Initial value of 5. T1 is 5. So this becomes our Tn plus 1 and this becomes Tn. That's how an iterative formula is written. The one which is isolated is n plus 1, which is the next one. In this case, it will be T2 2 because t1 is taken as 5, so I'll take 5 here. t2 equal to 9 over 1 plus natural log of 5 plus 3 over 2. Whatever answer I get in 5 significant figures here, I will substitute in here and I'll go to T3 and so on. I'm fast forwarding this process for you guys. Okay, so I got the answer here. 3 significant figures they said. So 3 significant figures here would give me 4.95. This is giving me 4.96. And this is giving me 4.96 again. So 2 consecutive iterations are giving me same 3 significant figures. So that becomes our answer. T is equal to 4.96. Prove that this identity is true. And they will have one line extra here. Okay. Sin 2x cot x plus tan x is equal to cos 2x. That means everything should be in terms of cos or sine. So let me change these two first. Okay, let's see how it's going to help. So sin 2x, focusing on LHS, left hand side. Okay, sin 2x, let me rather make this also as sine and cos. So we have an identity that sine 2a is equal to 2 sine a cos a. And that's what I'm going to do here. 2 sin x cos x is this one. And bracket cot x is cos x over sin x. And then we have 3 tan x. So 3 sin x over cos x. Hopefully this will give us something in terms of cost. Okay. So let's keep it as it is because nothing is going to change as of now. Sin x cos x remains this. The two parts I want to merge them because these are 2 but with a negative. That means I have to combine these two, and for that I need to have LCM, which will be sin x cos x. Since this rational part has sin x already, so it needs cos x. So cos x will multiply with cos x, gives us cos square x, plus sine multiplied with sine, 3 sine square x. Okay, now we can see this and this can cancel out. So it was a wise idea to make that also like this. So 2 cos square x, can I write this as plus sine square x plus 2 sine square x? Can I? Because 3 broken into 1 and 2 here. Why? Because this is 1. Yeah, then identity says cos square plus sine square x is equal to 1 plus 2 sine square x, right? But it is nowhere near to this one right now, isn't it? So what will we do? We know an identity that cos 2a is equal to 1 minus 2 sine square a. Also it is equal to cos 2 cos square a minus 1 is the same thing, right? Let's try to, because we have sine square x here, let's say focus on these two. Or let's look at this identity. So I'll bring 2 sine square here. So 2 sine square a is equal to 1 minus cos 2a. That's what I can write. Yes. So 2 sine square a, this one, I will write as 1 plus 1 minus cos 2a, which becomes 2, and 1 plus 1 is 2 minus cos 2a. And if I open this bracket, I get 2 times 2, 4 minus 2 cos 2a, and that is exactly the RHS, hence it is proved. What next? Hence find the exact value of cos 1 over 12 pi, cot, and 3. So cot 1 over 3 tan over 5. Okay, and they are not asking this sine 2. So let me I will change this one. Let me change this one. Cot x plus 3 tan x is equal to 4 minus 2 cos 2x divided by sine 2x. Yeah, I rearranged it because next part is about this one, cot x plus 3 tan x. Cot x plus 3 tan x. So I removed the one which was not there to the other side. So basically I have to solve this one according to them. So I will write it here, 4 minus 2 cos 2x. Okay. So this one becomes 4 minus 2 cos 2x. Cos 2 and x, in place of x it is 1 over 12 pi. Divided by sine x, no, not sine x, sine 2x it was, sine 2x. Okay, sine 2x. Sine 2, 1 over 12 pi. Hence find the exact value. So we can find it now. 4 minus 2 cos pi by 6, because 2 and 12 cancel. Divide by 2 and 12 cancel again, sine pi by 6. So which will be 4 minus 2 cos pi by 6 will be square root 3 over 2, and sine pi by 6 is half. This 2 and this 2 cancel. So what are we left with? 4 minus square root 3 over half. Yeah, I'm not writing 2 because denominator of a denominator becomes numerator, so 2 will multiply with numerator. So answer will be 8 minus 2 square root 3. This is the exact value of this particular expression. All right, and we move on to the final part of this final question. The diagram shows the curve with equation 4 minus cos 2x. Yeah, 4 minus cos 2x, the same thing. 4 minus 2 cos 2x is here. So it is saying 4 minus, 2 cos 2x. At the point A, the gradient of the curve is 4, somewhere here. That means the differentiation of this is 4 gradient. The point B is minimum, okay. The x coordinate of A and B are A and B respectively. From A and B, we have to find what? This. Okay, so first we should know what are A and B. That is our first challenge. So B can be found easily because it's a minimum point. At minimum point, the gradient is 0. So if I differentiate this one and make it equal to 0, I'll get the x coordinate of B. So let me differentiate this. dy over dx is equal to, differentiation 4 is 0, so ignore. Minus 2 is a constant, remains minus 2 cos 2x. The differentiation cos 2x is minus 2 sine 2x. So it becomes 4, positive 4 sine 2x. And for point B, 4 sine 2x will be equal to 0. So sine 2x will be equal to 0 divided by 4, which is 0. This 4 divides here, which is 0. So 2x equal to sine inverse 0. And sine inverse 0 in terms of pi, right? Yeah, for pi's we need. So 2x equal to, okay, sine 0, we'll not look at this graph, but we'll look at the other graph of sine. Where is it 0? In first two parts, okay? There are two minimums here. Can you see? The first is, it is at 0 itself. So yes, it is at 0 because 0 divided by 2. Okay, so first answer is 0. And second one will be 2x equal to, here it is pi. And this is 2 pi, right? But if you see that this is 1 where it is 0, this is second where it is 0, this is the third one which we need. We need third one 2 pi, not pi. So this gives me x equal to 0 over 2, which is 0. And of course, this is 0. We don't need it, but we need this one. 2x equal to, rather, x equal to 2 pi over 2. So 2 and 2 cancel, x is equal to pi. So we got our b, which is pi. So in this case, I can write pi here. Now I need to find what is a value for a. So I can write for for a. They've given gradient is 4. So 2x, how much was it? 4 sine 2x. 4 sine 2x is equal to 4. So sine 2x equal to 4 divided by 4, 1. 2x is equal to sine inverse 1. And there is no other place where this is a gradient 4, right? Next is here. That means I need the first answer. And the first answer in my graph of sine x is where it is 1 is here. This is 1. And sine inverse 1 is pi by 2. So I can use this one. 2x equal to pi divided by 2. X will be pi divided by 4. So we got x equal to pi divided by 4 for a here. So I can write here pi divided by 4 now. And now I will integrate this as usual. So what will be the integration? Integration of 4 will be 4x minus, constant is 2, so leave it, cos 2x. The integration will be positive sine 2x and divided by the differentiation of the angle, which is 2 plus c, pi by 4 pi. Okay, so 4x and 2 cancels, so sine 2x plus c from pi by 4 till pi. Okay, now let's substitute the values here. 4 pi minus sine 2 times pi plus c minus 4 times pi by 4 and minus sine 2 pi by 4 plus c. First thing first, cancel out c's. 4 pi minus sine 2 pi, we can see here sine 2 pi is 0. This is the graph of sine, right? 0. So minus 0 minus 4 and 4 cancel, pi minus and minus positive, sine pi by 2. Sine pi by 2 is 1. So 4 pi minus pi is 3 pi plus 1. This is the definite integral, and this is what they are asking us to show. And this concludes our solution video of paper 22, winter 2023. I hope you liked it. If you did, please share with your friends, give it a thumbs up, and subscribe to Math United. Only 8% people are subscribed to my channel, which is not motivating enough. So please subscribe to Math United. Thank you very much.